Welcome. Let's solve Leetcode 2981, find longest special substring that occurs thrice 1. Let's go over the problem statement. You are given a string S that consists of lowercase English letters. A string is called special if it is made up of a single character. Return the length of the longest special substring of S, which occurs at least thrice, or -1 if no special substring occurs at least thrice. And they define the definition of a substring. A substring is a contiguous non-empty sequence of characters within a string. Okay, so let's go over these 3 examples. Example 1, the result is 2, being that we can look at this substring with these first 2 A's. So at this point, we have one occurrence of 2 A's of length 2. Here we have the second occurrence of the double 2 A's of length 2, and here we have the third occurrence of 2 A's of length 2. Hence, the result is 2. Looking at example 2 here, there is no substring that occurs at least thrice, at least 3 times, so we return -1 here. And in this case, there's an A in the first location, A here, and an A here. So there is a substring that occurs thrice, and that length of that substring is 1. Okay, I think the problem statement is straightforward, so let's move on how we'll solve it. We'll be using a caching approach, and that should be fine and good enough for us to solve this problem. It'll be straightforward, and I like it. It's clean. So what we'll do is we'll keep accounts of the character and the length of that, and the length. And what we'll do is this will be the key, and the value will be the number of times we've seen it. So something like this, or just in order to get started, maybe. So we'll call this counts, and it'll be a default dict, and this will be an int to store the number of times we've seen it. And what we'll do is we'll loop through our string to perform this count. So let's do it. Let me show you how we'll do it. For example, using that example that they gave us. So if S equals A, we'll just use that example. So what we'll do is we'll loop through this string, and we'll use an enumeration. So we'll say so start, and then we'll say and the character. I'll just use char for now, and then we'll enumerate s. So what will happen is for every character we'll have a length of 0. We'll start off with the length of 0. Length is 0. This is the length of the substring. And then we'll start at every character. So for this, for example, here we'll start here, and then we'll loop as far as we can. And then the same thing for this one, for this character. We'll start here, then we'll loop as far as we can. And what we'll do is we'll check if the next letter is the same as the previous letter, and just keep doing that. And we'll just go as far as we can. Okay, and then we'll store that, and we'll store the result in our counts here. So let's do that here. So we'll call this for stop in range, and what I'm going to do is put we'll just say length of string. So we're going to start, and we're going to start for this inner for loop. We'll actually start at the stop location. Sorry, this stop value is the same as this start value, because if you notice this is 0, so if we start at the same location, we'll have a length of 1. Okay, just so I wanted to make that clear. If I wanted to, I could probably do something like put 1 here and put start +1. I could do that, but it's probably a little bit cleaner if we do it like this, and I'll show you why. It'll become clear. So what we do is we check, we compare the letter at stop. So compare letter or character at stop with the letter at start. That's one approach. So that would look something like this. Just S of stop, or actually, well, the letter, letter at stop. This is the letter at stop, and the letter at start was this char here. So you can use that. And if they are equal, we can increment our length. If equal, then we can increment our length. So this is the length just for this particular starting point. In addition, we can also increment our counts. So our counts would be, so in addition, increment our counts. And remember, our count stores that letter, so we'll call it char, and that length. Okay. What we can also do now is, if this value is bigger or equal to 3, and so we can do, we can also track our maximum length. What I mean by that is this: if this counts value is bigger than 3, we know we want it. We know we want to store it. So what I'm going to say is, okay, if counts of this guy, we'll just use that, it's fine. If this is bigger than or equal to 3, we can update our maximum length that we're storing. So we just have this first check. We check if there are 3 of those that we have seen, we can store update our max length maybe with length. So again, I want to make that clear. If we've seen some substring at least 3 times, then we can update our max length. Otherwise, so this is in here. If these characters are equal, we do all this. If not, then we just break. So let me give you an example. So suppose we're here. Suppose this is a B. So we start here at A and we say, okay, A equals the next guy, so that's good. So now stop would be here at index. So this is going to be 0, 1, 2, 3. So start here would be at 1, and for this we can loop here. This stop would first be at 1, then it'd go to 2, then stop at some point would be at 3. Now if they're not equal, if A and B are not equal, then we just go here and we break, because we know that this substring length can't grow anymore, so we would stop. So that's why we have the break here. And we just keep doing that for all of the letters. And lastly, we can just return our maximum length that we've been updating all along. So we've been updating this max length all along, so we can just update it. And that's basically it for the how we'll approach it. And there are some minor details that I'll go over the actual implementation, but other than that, that's it. Okay, so let's get started. So we'll loop through the our string. So for start and character and enumerate s, and we'll set the length equal to 0. And then we'll perform another for loop, and we're gonna go starting from here. We're gonna see how far out we can go. Okay, so let's how far out we can go. So for stop in range start. Now I'm gonna put this here as the length of, I'm gonna store the length of the string here. So n equals the length of s. Okay. And then we compare if this character here that we started with is the same as the letter that we're incrementing to. We're expanding from. So s stop. And while this will be true for the first letter, we don't know how much farther than that, but we know at least it'll go in here once. So if that's true, we increment length plus equals 1. Then we update our counts. So counts that letter and the length. And we say plus equals 1. Okay. Now we can, if necessary, we can update our maximum length. So what I'll do here is I'll put I'll set our maximum length equal to -1. And so if this, yeah, so you'll see here. So if counts, let's copy this down. If this is bigger than or equal to 3, well, let's do something else, sorry. And length is greater than max length, well, we can update max length. And that'll make it easy for us. So at the end, we can just simply return max length. That would be nice. Again, because we've been updating it all along. And what else? Sorry. So here, if the characters match, we keep moving forward. If they don't match, we simply break. And we move on to the next letter. And that's the answer or the solution in essence. Since we have 2 for loops here, the complexity would be, well, O(n) squared. Well, let's run it first, and I think we'll be fine. So let's check this out. Okay, it looks great, and let's submit it. Okay, so although it's 26 milliseconds is extremely fast, it's somewhere towards the end, but that's fine. Reason being is that there is a follow-up to this problem. So this is version 1, Thrice 1. There is a Thrice 2, which has stricter limits, which has, yeah, the string is, I think, 500 characters, I'm not sure, but it's much longer. And in that case, that problem required an O(n) solution. So what I think is some people used the O(n) solution for Thrice 2 in this problem, which gave them a faster runtime. That approach wasn't necessary for this problem, so I didn't go over it. If you would like to see the O(n) solution, let me know in the comments, and I'll do it. But for this problem, this is perfectly fine. Again, it ran in what, 20, 23 milliseconds is not a long time. So this is perfectly fine. And if you liked it or you felt it was in any way educational, give a like or subscribe. Other than that, have a wonderful day. Take care.